Hi everyone, welcome to Infinity Learn by Sri Chaitanya. My name is Vibhati and in today's session I'll discuss PYQs of motion in a plane and projectile motion. Okay, so let's start today's session. But before that guys, you are on Infinity Learn NEET channel, तो इसको फटाफट से सब्सक्राइब कर लो और जो बेल आइकन है उसको प्रेस कर लो ताकि आपको जो नोटिफिकेशंस हैं वो आते रहें अगले सेशंस के. ठीक है, so let's start with question number 1. Question number 1 is the x and y coordinates of the particle at time t are x is equals to 5t minus 2t square and y coordinate is given as 10t. Okay, where x and y are in meter and t in seconds. So the acceleration of the particle at t is equals to 2 seconds is. ठीक है, t is equals to 2 सेकेंड पे एक्सेलरेशन ऑफ द पार्टिकल क्या होगा. तो पार्टिकल का x और y कोऑर्डिनेट टाइम के साथ चेंज हो रहा है, मतलब पार्टिकल टू डिमेंशनल मोशन परफॉर्म कर रहा है. ठीक है, सो अगर मैं dx by dt करूं तो मुझे क्या मिलेगा, वेलोसिटी अलोंग x एक्सिस विच इज डिफरेंशिएशन ऑफ 5t minus 2t square. So this is 5 times differentiation of t which is 1 minus 2 times differentiation of t square that is 2t. तो ये हो जाएगा 5 minus 4t. नेक्स्ट इज, इसको अगर मैं फर्दर डिफ्रेंशिएट करूं तो मुझे मिलेगा एक्सेलरेशन अलोंग एक्स एक्सिस, राइट. सो ए एक्स विल बी डी वी एक्स डिवाइडेड बाई डी टी. सो दिस विल बी डिफ्रेंशिएशन ऑफ y इज 0 माइनस 4 टाइम्स डिफ्रेंशिएशन ऑफ t विच इज 1. ओके, सो दिस इज माइनस 4 मीटर पर सेकेंड स्क्वायर. सो एक्सेलरेशन अलोंग एक्स एक्सिस क्या आ जाएगा, माइनस 4 मीटर पर सेकेंड स्क्वायर. Now y is given as 10t. So dy by dt will be velocity along y axis which is 10 times differentiation of t which is 1. So this is 10 meter per second. And acceleration along y axis will be dvy divided by dt. तो ये हो जाएगा differentiation of 10, it is a constant quantity, तो 0. So acceleration along x axis is minus 4 meter per second square whereas along y axis it is 0. So net acceleration क्या हो जाएगा, minus 4 meter per second square which is option B. Okay. Next is this question. A particle has initial velocity 2i cap plus 3j cap. This is u vector and acceleration a vector as 0.3 I cap plus 0.2 J cap. We need to find the magnitude of velocity after 10 seconds. ठीक है, तो V vector आपका क्या हो जाएगा, U vector plus A vector into T. ठीक है, U vector आपका है 2 I cap plus 3 J cap plus A vector is 0.3 I cap plus 0.2 J cap into T is 10. तो ये आ जाएगा 2 I cap plus 3 J cap plus 3 I cap plus 2 J cap. So this is 5 I cap plus 5 J cap, right? So this is velocity vector. हमें क्वेश्चन के आंसर में मैग्नीट्यूड बताना है, right? So magnitude of V vector will be under root of 5 square प्लस 5 स्क्वायर. सो ये हो जाएगा 25 प्लस 25 विच इज 50 स्क्वायर रूट. सो ये आ जाएगा 25 इंटू 2. सो दिस इज 5 रूट 2. सो 5 रूट 2 यूनिट्स इज द आंसर. नेक्स्ट इज सिमिलर टाइप ऑफ क्वेश्चन विद डिफरेंट वैल्यूज ऑफ वेलोसिटी. ओके, सो इनिशियल वेलोसिटी u वेक्टर इज गिवन एज 3i cap plus 4j cap and acceleration vector as 0.4 I cap plus 0.3 J cap. ठीक है, again we need to find the speed after 10 seconds. Alright, so यहाँ से अगर आप देखोगे तो V vector is u vector plus a vector into t. u vector क्या हो जाएगा, 3i cap plus 4j cap plus a vector is 0.4 I cap plus 0.3 J cap into T which is 10. So ये आ जाएगा 3 I cap plus 4 J cap plus 4 I cap plus 3 J cap. So this is 7 I cap plus 7 J cap. So अगर आप इसका मैग्नीट्यूड निकालोगे टू गेट द स्पीड, तो मैग्नीट्यूड आपका जो आएगा दैट इज अंडर रूट ऑफ 7 स्क्वायर प्लस 7 स्क्वायर विच इज 7 रूट 2 यूनिट्स, राइट? सो करेक्ट आंसर इज ऑप्शन बी. ओके, नेक्स्ट इज this question. It was in 2019 paper. Question is, the speed of a swimmer in still water is 20 meter per second. So velocity of swimmer with respect to river is 20 meter per second and speed of river water, मतलब velocity of the river is given as 10 meter per second. And it is flowing due east. If he is standing on the south bank and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to north is. So basically, अगर ये आपका river है, so swimmer यहाँ पे खड़ा है, swimmer जो है वो सीधा ऐसे जाना चाहते हैं यहाँ पे, मतलब ड्रिफ्ट जो होगा swimmer का, दिस ड्रिफ्ट शुड बी जीरो. ठीक है, ड्रिफ्ट क्या होना चाहिए? जीरो होना चाहिए, राइट? वेलोसिटी ऑफ रिवर ऐसा है एंड लेट्स से कि स्विमर जो हैं वो थीटा एंगल से नॉर्थ के साथ स्टार्ट करते हैं. फाइन, तो इस केस में अगर आप कंपोनेंट लोगे, सो दिस कंपोनेंट इज वी एस आर कॉस थीटा and this component of VSR is VSR sin theta. ठीक है, अब ड्रिफ्ट जीरो है मतलब स्विमर के पास नेट वेलोसिटी इन दिस डायरेक्शन शुड बी जीरो. ठीक है, सो अगर आप ग्राउंड से देखोगे, ग्राउंड से इस चीज को ऑब्जर्व करोगे तो आपको क्या लगेगा कि स्विमर जो हैं वो VSR sin थीटा से ऐसे जाना चाहते हैं और VSR cos थीटा से ऊपर जाना चाहते हैं, लेकिन एट द सेम टाइम रिवर इनको घुमा के ऐसे लाना चाहती है. ठीक है, फाइन. सो बेसिकली अगर आपको एकदम वर्टिकली ऑपोजिट जाना है यहाँ पे, तो नेट ड्रिफ्ट जीरो होना चाहिए. ड्रिफ्ट मतलब कि यहाँ जाना चाहते थे, यहाँ पहुँच गए, तो ये डिस्टेंस आपका ड्रिफ्ट हो जाएगा. ड्रिफ्ट इस डायरेक्शन में आ रहा है, मतलब नेट वेलोसिटी अगर इस डायरेक्शन में कुछ हुई तभी ड्रिफ्ट आएगा, है ना? तो अगर ये वेलोसिटी जो है ग्राउंड की रेस्पेक्ट में स्विमर की जीरो हो जाए तो ड्रिफ्ट क्या हो जाएगा? जीरो, बिकॉज दिस वेलोसिटी इज रिस्पॉन्सिबल फॉर प्रोवाइडिंग ड्रिफ्ट, राइट? सो VSR sin थीटा शुड बी इक्वल टू VR, है ना? सो sin थीटा should be VR upon VSR. VR क्या है? 10, VSR is 20, so sin theta is 1/2, so theta is equal to 30 डिग्री, है ना? So basically उनको ये 30 डिग्री एंगल बना के स्टार्ट करना पड़ेगा so that वो सीधा ऐसे ऊपर पहुंच जाए. फाइन, सो करेक्ट आंसर जो होगा that is 30 डिग्री वेस्ट. I hope this is clear guys. Hello Bartaval, hi beta. Excellent. Okay, next is this question. This was in 2014 paper, very nice question actually. The projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle theta with the horizontal. So we have earth surface and we are firing one projectile with velocity 3 meter per second. 5 meter per second and the angle is theta. This is earth. Okay, another projectile fired from another planet with a velocity of 3 meter per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. So let's say this is another planet, है ना, यहाँ पे this is something else. Let's say this is planet X. And we are firing same projectile at the same angle but 3 meter per second. Let's say acceleration due to gravity of this planet is gp and acceleration due to gravity on the earth is 9.8 meter per second square. ठीक है. Now in this condition, these two projectiles will follow identical path, identical trajectory. Okay, so in this case, what should be the value of gp? That's our question. So they are following identical trajectory, matlab equation of trajectory should be similar, right? Equation of trajectory is what? Y is equals to x tan theta minus gx square upon 2u square cos square theta. ठीक है. Now everything is similar, x and y, theta is similar, only difference will be of g and u in this equation. So if this equation is identical for both of this projectile, so what will happen? This entire thing should be identical. So x tan theta term is identical for both the projectile because theta is similar, x is similar. Over here again cos square theta will be identical, x square will be identical, 2 will be identical. So in order to make these two equations similar, g upon u square should be same for both the projectiles or in both the cases, right? So g for earth is 9.8 divided by u for earth is 5 square is equals to g for planet divided by u for planet, which is 3 square. So gp will be 9.8 into 9 divided by 25. So this is the acceleration due to gravity on this planet X. Okay, and that is equal to approximately 5.9. Okay, 5.7 or 5.9. Okay, so correct answer will be option B, right? Next is from 2013 paper, we have a projectile. Velocity of the projectile as 2i cap plus 3j cap. So this is point A from where the projectile is fired. So at this point velocity is 2i cap plus 3j cap and this is point B. So after some time it will strike the ground with some velocity v. We need to find velocity of this projectile at point B. So 2i cap plus 3j cap. So 2i cap, this is x-axis and this is y-axis. So along x-axis velocity will be constant, right? It will be 2 throughout this motion because there is no acceleration along x-axis. ठीक है? So velocity will be constant for x-axis. So initial and final both the components will be same for x-axis which is 2. तो final velocity का x component तो मिल गया 2i cap. ठीक है? अब क्या होता है कि प्रोजेक्टाइल जो है जिस वेलोसिटी से जिस स्पीड से जाता है उतनी ही स्पीड से वापस स्ट्राइक करेगा बिकॉज हम एयर रेजिस्टेंस नहीं कंसिडर कर रहे हैं. फाइन. तो अगर ये 3 मीटर पर सेकेंड से y एक्सिस के साथ स्टार्ट किया तो ये 3 मीटर पर सेकेंड से ग्राउंड को क्या करेगा? स्ट्राइक करेगा, लेकिन डायरेक्शन रिवर्स हो जाएगा. तो अगर ये पॉजिटिव y एक्सिस है तो आते समय उसकी फाइनल वेलोसिटी नेगेटिव y एक्सिस की तरफ होगी, राइट? सो फाइनल वेलोसिटी जो होगी वो 3 ही रहेगी लेकिन विथ डायरेक्शन रिवर्स्ड, राइट? सो इन दिस केस अलोंग y axis it will be minus 3j cap. Okay, so correct answer is 2i cap minus 3j cap, which is option A. Next is this one from 2012 paper. Okay, well done, well done. The horizontal range and maximum height of a projectile are equal. The angle of projection of the projectile is. Okay, so very nice question. Range is equal to height. ठीक है. So in order to solve this types of question, we use R upon H technique. R upon H is equals to 4 upon tan theta. Okay, this is the R upon H relation. R upon H is equals to 4 upon tan theta. But R is equal to H, so R upon H will be 1, which is equals to 4 upon tan theta. So in this case, tan theta is equals to 4 and theta is equals to tan inverse 4. So correct answer is option B. Theta is equals to tan inverse 4. Okay? I hope this is clear, right? Next is this one from 2011 paper. Question is, a missile is fired for maximum range. Missile is fired for the maximum range with an initial velocity of 20 meter per second. Fine. G is 10 meter per second square, the range of the missile is. So if you are firing any missile for maximum range, angle of projection should be 45 degree. So maximum range will be what? U square sine 2 theta divided by G, which is U square upon G into sine 2 times 45 degree. Sine 2 times 45 degree is nothing but sine 90 degree, which is 1, right? So maximum range will be U square upon G. U is given as 20. So R max will be 20 into 20 divided by G as 10. So this will be 40 meter, right? 40 meter is the maximum range, which is option A. I hope this is clear, right? Chalo, excellent. Next is from mains 2011 paper. The projectile is fired at an angle of 45 degree with the horizontal elevation angle of the projectile at its highest point as seen from the point of projection is. So very nice question. Let me explain this question to you now. This is ground level. We are firing this projectile at an angle of 45 degree, okay, with some velocity u. So it will follow a parabolic path like this. So this is the highest point of this projectile. So this, if you look at this highest point from the initial point, this will be the elevation angle theta for you. Okay, this will be the elevation angle theta for you, right? We need to find this elevation angle theta in this question. So this is nothing but what? Maximum height, and this complete is range R. So half of the range will be R by 2. So in this triangle, in this right angle triangle, if you draw this right angle triangle here, this is theta, this is R by 2 and this is height h. So in this case, tan theta will be what? Tan theta will be perpendicular divided by base, which is h upon R by 2, which is 2h upon R. Okay. So tan theta will be 2, height is u square sine square theta divided by 2g. So theta is 45 degree divided by 2g divided by R is u square sine 2 theta, which is 2 times 45 degree. So this is 2 into 90 degree, 2 into 45, 90 degree divided by g. G cancel, u square cancel, 2 cancel. So we are left with sine square 45 degree divided by sine 90 degree. Sine 45 degree is 1 by root 2. So its square will be 1 by 2 divided by sine 90 degree is 1. So we have tan theta is 1 by 2. Okay. Tan theta is 1 by 2. So theta will be tan inverse 1 by 2, which is option C. Okay. I hope this is clear, right? Excellent. Next is this question from 2019 paper from circular motion. Two particles A and B are moving in uniform circular motion of concentric circles of radii RA and RB with speed V and VB respectively. The time period of rotation is the same. the ratio of angular speed of A to that of B will be. So, time period of A is equal to time period of B, and we need to find omega A upon omega B. But we know that omega is 2 pi by T, right? So, this is 2 pi upon TA divided by, for omega B, this is 2 pi divided by TB. 2 pi cancel, since TA is equals to TB, TA cancel, so this is 1. So, ratio of angular speed of A to B is clearly 1:1, which is option A. Next is this question, it was in NEET 2016 second paper. In the given figure, A is equals to 15 meter per second square. This A is 15 meter per second square, represents the total acceleration of a particle moving in a clockwise direction in a circle of radius 2.5 meter at a given instant of time. The speed of the particle is. So, basically this is the situation. Let me draw this circle here. This is center, this is the radius, and A over here is like this. This is total acceleration of the particle, which is making an angle of 30 degree with the radius over here. Okay? So, we need to find speed of the particle, and radius of the particle is given as 2.5 meter. Okay? Radius of the particle is given as 2.5 meter. So, this is total acceleration. Let us take component along the radius and perpendicular to the radius. So, this component will be A cos 30 degree, and this component is A sin 30 degree. So, this is tangential acceleration. This is centripetal acceleration along the radius and towards the center, right? So, in this case, AC is A cos 30 degree, and that is equal to V square upon R. Centripetal acceleration is given as V square upon R. Okay? So, V square will be A R cos 30 degree. A is given as 15, R is given as 2.5, cos 30 degrees root 3 by 2. Fine. So, this will be V square. So, if you solve this one, this will be, let us solve it. So, this is 5 into 3 into 5 into root 3 divided by 2 ka square, right. So, V square will be 5 square into 3 root 3 divided by 2 ka square. So, V will be under root of 5 square into 3 root 3 divided by 2 ka square, right. So, in this case approximate value of V will be, I think, 5.7 meter per second, which is option C. Okay, fine. I hope this is clear, guys. Okay. So, this is your question from circular motion. It was in the 2016 second paper. Okay, and if you have any doubt, just let me know in the comment section over here. Right. So, guys, that is it for today's session. We are also available on Telegram. You can join our Telegram group by Telegram channel by this link. This link is given in the description box. Go to the description box, आपको link मिल जाएगा. वहाँ पे you'll find assignment notes and daily updates. So make sure that you are joining this Telegram channel right now. And guys, like this session, share this session with your friends, and subscribe to our channel. Press the bell icon so that you will not miss any single session on this channel. Right, so that is it for today's session, guys. Thank you so much, everyone. I'll see you again on Thursday. Right, so take care, everyone. Bye bye.